Okay, guys. So again, welcome to Networkers Champ YouTube channel, and today we are going to discuss with this agenda. So as you see, we will be talking about the fine-tuning the overall OSPF network, and in order to fine-tune the OSPF network, we will discuss few features which are widely used across the OSPF network across the service providers and then the big network. Now, these all features what we're talking about, right? They are used basically, in terms of cost efficiency, in terms of, a proper management, right? And also lot of, in fact, when you're preparing for the interview, right? A lot of interview questions will come from these, topics. Or consider this way that each agenda topic here, right, will have, you know, few questions from the interviewer, right? So, for example, what is OSPF stubby area, right? What happens? What is the difference between OSPF stubby area and totally stubby area? What is NSSA and totally NSSA? What is the difference between them? In fact, matrix type, right? So when we are redistributing it, right? So what is the difference between matrix type E1 and matrix type E2, right? So these all are actually the interview questions. Now, to demonstrate all that, right, we are going to follow this topology, right? Let me brief you about this topology. So we have R1, R2, all the way up to R7, where R1 is indifferent, running R1 between R1 and R2, running some different protocol. In this case, we are running, let's say, RIP, okay? And R6 and R7, right? We are, so as of now, yeah, as of now, R5, R6, and R7, we are basically using different protocol, in this case, EIGRP. Okay, I will just change it. I will just change it to EIGRP. And then R2, R3, R4, R5, this is your OSPF domain. So let me just draw here. This is your OSPF domain. Okay, and this complete OSPF domain has been divided into different area. This is area 45. Area 45 is connected to backbone area. Area 23, which is connected to backbone area. That means R3 and R4 both are ABR, right? Now, as you are aware of, when you're redistributing some different protocol to the OSPF, the router where you're performing redistribution becomes the ASBR. So this is a ASBR at one end, and this is the another ASBR at another end. Okay, so that's the topology. We have already built the topology here. The configuration is already in place, the physical interface IP, right, as well as the OSPF. Both OSPF is, forming the neighborship across. And also, we have also redistributed these RIP routes into OSPF, OSPF routes into RIP. Same goes here. A redistributed OSPF into EIGRP, because here we are running EIGRP. This is basically part we are running EIGRP, and same EIGRP is redistributed to OSPF. Hence, end-to-end reachability we have between R1 to R7. And let's quickly verify this before moving further. Okay. Obviously, we will understand first these features, right, and then demonstrate parallelly. But let's first, go through the topology itself. So I'm going to clear all these things, and let me get the console first of all the routers. So, okay, and then let me share this with you guys. Now stay with me because as I told, this is going to be very, very, important session from the knowledge point of view, from the, interview point of view as well. I hope you guys are able to see this. So to demonstrate, basically, we are using the, this topology. Right. So as you see here, if I go to R1, I just wanted to quickly show you the configuration, show IP interface brief. We have some loopback addresses, right? And the serial link, which is connected to show CDP neighbor, R2. So let me go to R2 and do show run section, let's say router rip. And you see here, we are running router rip version 2, and then we are distributing OSPF, right? 100. So, and same goes to router OSPF. So, as we discussed, right, in R2 we are running OSPF also. So, this basically network which is going to, this particular network is going to area 23, but this network is going to RIP, right? So, we have this network advertised in R2. So, where is that RIP? This is basically 12.12 dot, right, which is serial 1 slash 0. And on serial 1 slash 1, it is 23 dot. So, let's see here. Okay. Now you see the redistribution is happening vice and versa, right? So inside of the OSPF, we are redistributing the RIP, right, with the matrix type 1 that we have used here. Okay. Now, whenever you redistribute, let's talk about this redistribution, right? Because we are at the same. So you see this matrix type I have mentioned. Okay. So whenever you redistribute, by default, matrix type 2 is redistributed. Okay, so let me quickly show you what I'm talking about. So router OSPF, let's say 100, and say redistribute RIP, right? And then here you have matrix type. You can define matrix type, and then you have 1 and 2. But if you don't define this matrix type, which one will be redistributed? By default, it will set to matrix type 2, right? But I have purposely here configured matrix type 1. Okay, so here I have configured metric type 1, but the other end on R5 over here, I have configured the metric type 2 itself. Okay, let me do one thing. Raise one layer and maybe just remove this for time being, and just raise this up to here, and then lower one layer, right? So this is not there in picture as of now. So let's remove it from the picture, right? So this is the scenario. Now, what is the difference between matter type E1 and E2? So as you see here, when it is E2, the default, right, metric is set to 20, and all the, this 20 would remain across all the OSPF network. So let's say you are redistributing here, okay, these prefixes you are redistributing into OSPF, EIGRP into OSPF, where you have set the metric default to, right, which basically it sets by default the metric 20 and it remains in the same. But in case of E1, every routers keep adding their own metric. So I mean, I can quickly show you. Um, let's say 172, okay, let's say any prefix over here. Which prefix? Let's say this prefix. Now just copy it and then go to R4 and say show IP route, right? And this. Okay, right? So you would see the metric here. will keep on adding. So OSPF distance, AD and matrix 148, right? If I go to R3, show IP route, and then this, you see. So here matrix it is 84 on R3. When R4 receives it, it adds the matrix. So it keeps on adding. Every router will keep on adding. But in case of R2, in case of matrix 2, the matrix would remain same across all the network, which is 20. That's the difference actually. Okay. So now talking about the reachability. So let's quickly verify R5 and R6 whether they are in good shape or not. So if I go to R5, show run section router OSPF, just to check the OSPF configuration. So yeah, I see that in R5 we are distributing EIGRP right into EIGRP into OSPF. And then in that case, let me also see router EIGRP. So show run router EIGRP, and we are redistributing, OSPF into EIGRP as well. So if I check in R7, which is the last router, show IP route, you would see all those external prefixes which are coming, uh, all the external prefix, which is this 172 range, as well as the OSPF, all OSPF prefixes are getting redistributed into EIGRP, and that we can verify here, right? So by looking at this picture, 172.16.101.0, right, which is 172, this one. Uh, these all are these all are the RIP routes which have been redistributed into OSPF and then OSPF to EIGRP. Same if I go and verify here, show IP route. Here as well, we are receiving all those prefixes which 192.168, 1.0, 1.32, 164, 1.96, and we see all those prefixes. So ultimately, if I ping, right, any of the IP here, let's say dot one, right, the reachability, I should have the reachability. No, sorry, it's it should be 192. Copy paste error, right? Here we go. And if I trace route the same, right, and I would just put numeric so that the trace route should be, quicker output. So it's going to 12.2, which is R2, then it is going to 23.3, which is R3, then 34.4, which is R4, then going to 45.5, which is R5, 56.6, which is R6, and finally 67.7, which is R7, finally. So that point traffic is going end to end. Okay. Now, let's understand these features. When we have achieved all that, communication traffic is passing through all that, now let's understand this part here, introducing stubby area types, right, and stub. Now before introducing this feature, which is stub area, right, let's understand the challenges here. The challenges, hold on. So the challenges, think of this way. This particular network is advertising some 5,000 routes, 5K routes. Okay. And this particular network is advertising some 5K routes, 5K routes, prefixes to the OSPF. So in this OSPF domain, you have finally 10K external routes, 10K external routes, which that means every router in the OSPF, let's say you have 50 routers in OSPF network. Okay, 50 routers. Now every router will carry 50, these 10,000 routes. Do you guys agree? Yes. So do you guys also agree to hold these 10,000 routes prefixes, right? Every router should be capable enough to handle. So ultimately, you can not actually buy lower end routers. You have to buy some, higher end routers, which will add the cost, isn't it? If you have 50 routers, right, in your OSPF, in this service provider, let's say, right, and think of this is service provider, right? This is service provider and working as a, and we're running some OSPF in this. So every router in this should be very capable to handle those 10,000 routes, right? Otherwise, if you buy any lower end router that cannot handle 10,000, and that would lead to, traffic congestion, that could lead to, traffic, the network down or situation or anything can happen. Now, my point here is if you want to purchase a router which can handle 10,000 routes, that router must be, expensive, must be higher end, right? Which must be expensive. That means you have to deploy all 50 routers, expensive routers. I'm talking about straight away cost here. Cost is involved, more cost is involved, right? But you may not need these 10,000 routes in other areas. Let's say this area 45, right? You may not need these all 10,000 routes. You may need only one route, or you may need only default route or something like that, right? In that case, how, let's say this area you do not need, all those routes, but because, we have this area which is coming in between, we have to think of this particular router is connected to another, router here, which let's say like this, and then this is another area, let's say another some uh, 20 area 20, right? And you do not need these 10,000 routes at all over here. Then how you can utilize, how you can ensure those routes? Yeah, there are features, you can summarize it, right? You can filter it, but after all, they also need the, reachability. If you filter it, if I mean it might not work, right? If you summarize it, yes, that's something you can do it, but again, you may not be able to summarize all the routes. This area routers still need some, or it would still install some of the routes. So in order to customize that cost, right, uh, we basically, use these features so that as per our requirement, we can add whatever, series of routers we want to add as per the requirement. It's There should not be any limitation that no, we have 10,000 routes, so we have to purchase this high-end router only, right? So that limitation is now removed with this feature. We call it actually stub area. So as you see here, in ABRs in stub area, advertise a default route into the stub area. Okay, hold on. Before that, you need to understand the LSA. We discussed LSA, right? Whenever ASBR advertises external prefixes to OSPF, that is LSA 5. We all know that, right? So that means this ASBR, when it is advertising these RIP routes to OSPF, it would be all LSA 5. And when these EIGRP routes are getting redistributed into OSPF, these all are the LSA 5. And you can see, let's go to R4, right, quickly and check here, show IP OSPF database, right? And here you see type 5 AS external link state, and these all are the, LSA 5 routes, which means being advertised from outside of the OSPF. You will also see summary ASB link, which is LSA 4, right? And then these are the LSA 3, right? These are the LSA2, router link state means LSA2. You remember DRBDR we discussed, right? And these are for the area 0, summary net link state, a router link state, right? On the area 0, right? So my point here is, this is LSA1, by the way, router link state. My point here is that they are receiving the all external prefixes. Now, what happens when you use this stub, right? So what happens, instead of in straightforward statement, I would say these ABRs, okay, instead of advertising LSA 5, let's say you configure this area as a stub. So first of all, stub you can only configure on the, not only stub, totally stub, NSSA, totally NSSA. You can only configure on the non-backbone, right? Only these features, what you see here, these features are only for the non-backbone. You cannot configure it in backbone. So non-backbone here we have area 23 and area 45. Let's talk about area 23. So when you configure this particular area as a stub, right? What happens when ABR connecting to that stub, which is in this case R3, when it receives all LSA 5 external prefixes, from here, instead of advertising these LSA 5 into stub area, it will generate a default route and advertise it to R2 or to the stub area. So all routers in this stub area would only carry the default route instead of installing LSA 5. I hope this is clear. What? ABR would not advertise LSA 5 to stub domain. Instead, it will generate default route and advertise. All stub routers will install the default routes only. So what happened now? Let's say R3 is receiving some 5,000 external prefixes from here. These 5,000 external prefixes would not be advertised to stub area. Instead, they would be only having one route, which is a default route. See what I did. I reduced those 5,000 routes. 5,000, I'm just taking an example. Five number of routes into one route, which is default route. Isn't it good? Right? Now you can add any router in this particular area that you want, because any router will handle, I mean, some of the routes. Is it clear? So let's understand this in more detail. So it says advertise default route into the stub area. At the same time, the ABR chooses to not advertise external routes LSA 5 into the area, or even instead do not advertise inter-area routes LSA 3 into the area, right? What? No, this statement might not be correct. Do not advertise inter-area routes, which is LSA 3. Forget about this statement, okay? Stub area only filters out LSA 5, and we will see in the lab, right? All routers in the stub area can still route to the destination because they have the default route, right? But the routers require less memory and processing because we are finally utilizing, customizing it, right? Some of the features of stub area, which you should know. ABR creates a default route using type 3 LSA. Okay, it is okay. So the default route, what it is saying is that default route that it installs, it is inter-area default route. That's what it is saying. Okay, I will show you what it means. Listing subnet like 00 and mask 00 and flood that into the stub area. ABRs do not flood type 5 LSAs into the stub area. We discussed the default route has a metric of 1. Whenever it installs default route, the metric is 1. Routers inside stub area cannot redistribute external routes into the stub area. Now, this is one limitation. Just make a note of it. Routers inside of this stub area cannot redistribute. Okay, so that means R2 is redistributing rip into OSPF, OSPF into rip. If you configure this area as a stub, you won't be able to redistribute. Okay, let's see this in our lab. So what I'm going to do, and also another question or another key point, all routers in the area 23 that you are going to configure as a stub, all routers should participate, in stub flag, otherwise they will not form the neighborship. Means if you configure, let's say R3 here for this area 23 as a stub, if you don't configure stub R2, right, it will not form the neighborship. And that we have discussed, this is stub flag is there in the hello packet, right? So let's understand this. I'm going to straight away go to R3 and configure router OSPF 100, uh, router OSPF 100 and say area 23 and say stop. That's the only command. Before configuring this, let's verify do show IP route OSPF. Okay. And you see all E2 routes, all external routes we have, all E2 routes, right? Or include, let's say, E2 only. So these are the E2 routes that we are receiving, external routes. Okay. Now let's go ahead and configure. So the first thing what you would notice, R2 will break the adjacency from R3. And here we go. OSPF process neighbor 222 down. Neighbor adjacency forced to reset. Why? R3 is sending hello with stuff flag. R2 is sending hello with normal flag, no stuff flag, right? This should match, and that is why they're not forming the neighborship. And you can verify here do show IP OSPF neighbor, and there is no 222. It is down. You see that? So as soon as you go here and say, router OSPF 100 and say area 23 and can stop, you will notice one more thing here. This. It says OSPF stub command is invalid when it is ASBR. I told R2 is ASBR because it is redistributing. So you need to remove those redistributing first. So let's go ahead and redistribute. I would say, what was the redistribution command? I'll simply just go ahead and copy and paste this. I would say no redistribution, right? Router rip. I'll go to under the rip and also remove this redistribute SPF 100 metric and say no. So I've removed. Now I'll go again to router OSPF 100 and say area 23 stop. Okay, looks like there's something, some reference command. Let's check here. To show run. Okay, redistribute. This command is still there. So no redistribute rip. Now here we go. So area 23 stop. So as soon as you configure, the neighborship has come up, right? Let's verify. What we have studied here, R3 would generate the default route, right? Let's go to R2 and say do show IP route, okay? And what you would see, you're not seeing any E2 routes now. Do you see any E2 routes here? All LSA 5 is now getting converted into inter-area route, IA, the default route. Do you see that? There, there is no any external routes. So what is happening? R3 is still installing those routes. You see, do show IP route when I do. R2 3, which is ABR, is still installing those routes. Now, instead of advertising these LSA 5, R3 is advertising inter-area default route to this stub domain. That makes sense? Now, here the limitation is that the router, the part of stub, cannot be ASBR, right? So ultimately, the traffic, this particular, the reachability to this external domain would be from R2. From R2, it can still reach here, but there would not be end-to-end communication between R1 and R7. Okay, so the stub is only feature that that you can implement when you know that there is nothing behind it. There is nothing behind R2. If there is something behind R2, stub is not the applicable actually feature that you should use. But let's say for a moment there is nothing behind. Think of this, there is nothing behind this R2. Okay. But even though if there is nothing using this stub, R2 is still installing lot of routes, lot of you know inter-area routes, OSPF routes and all. Do you see that? All those routes, right? Now, what if the OSPF itself is generating lot of, many routes? Let's say 5,000 coming from here, 5,000 coming from here, and then internal network, there are some, 2, 3,000 routes. With stub feature, R2 will still install inter-area routes, all OSPF routes, which it is installing. You see that? Include O or include O. You see, all OSPF routes it is installing. Now, that is why we have another feature which is called this totally stubby. What totally stubby says that okay, now I would create a default route for LSA 5 as well as for LSA 3. You see, ABR create a default route using type 3 LSA listing this. ABR do not flood type 5 and type 3 LSAs into the stub area. Now totally stub says okay, I would, you know, suppress or synchronize even type 5 and type 3 both with the default metric of 1, right? Same would remain, same concept. Routers inside stub area cannot redistribute again on this also, right? And all routers in the area must be configured to be totally stubby. So what I'm going to do now, I am going to remove this stub and configure totally stub here, and then we will see the difference. So let's go to R3, remove this, I would say no, and say area 23 and stub totally. What's the command? No summary. Stub and say no summary, right? So you would see here that when you configure stub and no summary, R2 will break the neighborship, and I would simply say area 23 no stub, remove this and say area 23 stub and no summary. So as soon as I configure, the neighborship is formed. Here we go. Now let's verify. When I do show IP route, and here we go. You see? Hold on. It is not receiving yet. Here we go. R2 is not even installing any inter-area routes as well as LSA 5. Instead, it is just installing a default route, which is inter-area default route. if I say do show IP OSPF database, it has only, you know, the uh, submarine link state and the router link state, nothing else. R3 again, on the other hand, R3 will still carry install all those routes. So if I go here and say do show IP route, you would see all those routes, right? So ultimately R3 is installing it because R5 is advertising to R4, R4 is advertising to R3, R3 is suppressing or creating a default on advertising to totally stub. Okay, so with this also, the totally stub routers cannot be ASBR, so the redistribution is not possible, right? So there should not be anything behind this totally stub. Now, so let's say now story changes. Later, you have a requirement that one customer wants to, connect with you, and customer wants, one connection, and they want to, communicate with this particular, customer, or maybe their branch office or whatever it is, and they want to use your network as a transit, right? And obviously you will charge, right? You will charge them saying, hey, I have already network built. You can use my network, right, to send the traffic for the communication, isn't it? So when the new customer is added here, now the limitation is that you cannot redistribute these routes, right? You cannot redistribute these routes, so the communication won't happen. What is the solution? And this is where you have another feature called not so stubby area NSSA. Okay. So NSSA says, okay, I would let any of the router which is a part of NSSA redistribute or can redistribute. Okay. Can redistribute. But then just remember, in NSSA uh, or stub or totally stub or NSSA, LSA 5 is not allowed. We have seen that. ABR generates LSA 5 into default route. Only ABR has that capability. When these prefixes you are redistributing into OSPF, this would come as a LSA 5. LSA 5 is not allowed here, isn't it? Because AR2 is not a ABR, it is ASBR. Then what? Let's do that and then see. So first, LSA 5 is not allowed on stub and totally stub area, a feature that originally caused some problems. The problem is based on the fact that stub area by definition should never learn type 5 LSA. So, and OSPF injects external routes into OSPF as a type 5, right? So, in order to ensure the reachability even after using the NSSA, what ASBR does, ASBR convert this LSA 5 into LSA 7. You have you noticed here? This LSA 7. NSSA external created by ASBR inside an NSSA area instead of type 5. So actually it is the LSA 5. But since LSA 5 is not allowed in NSSA, what ASBR does, it converts LSA 5 into LSA 7 and then advertise into NSSA domain. When R3 receives that LSA 7, R3 converts this LSA 7 back to LSA 5 and advertise it to rest of the routers. So the process is you redistribute. So let's go ahead and first redistribute. But before redistributing, remove no area 23 stub, no summary, and then also this. Let's go to R2 as well and say no, and then this also. And then I would go ahead and configure area 23 and say NSSA. Done. Area 23 and NSSA. Here we go. So I have configured NSSA, but I haven't redistributed yet. But let's see what is happening. Okay. R3 is still having do show IP route. All those routes. When I go to R2, do show IP route. R2 is not having anything. R2 doesn't have what? Any external prefix. Neither it has any external prefix, nor it has the default route. You see that? Right? But let's first redistribute. So I'm going to redistribute rip, right? Uh, say metric type 1 and say subnets. So all rip routes would be redistributed, and you see the command it is accepting. I will go to router rip now and say redistribute OSPF metric 2, OSPF 100 and say metric 2 anything, right? So vice versa I have redistributed. Now when I have redistributed, one thing you would notice, this ASBR would advertise this LSA 5 as LSA 7. Let's see. So if I go to R3 and again do show IP route, you would see one thing here. What? The N1. Do you see these N1 routes? N1. N1 and N2, it is similar like E1 and E2. Okay. N1 means NSSA, E1 means to not usually normal. So the same concept like if it is N1, metric will keep on adding. If it is N2, metric would remain same as a 20, right? So you see here N1. So the theory behind is R2 is converting this LSA 5 into LSA 7 and advertising it to NSSA. When R3 receives, let's go to R3 and quickly verify this. Do show IPOSPF database. And you would see here that R3 has type 7 AS external link state. All those prefixes what being advertised, in RIP and redistributed into SPF. You are seeing as a type 7 AS external. But then R3 will again convert this LSA 7 into LSA 5 and advertise to R4. So the same I can verify here. If I go here and say show IPOSPF database, you would see in R4 there is no type 7 LSA. It has only type 5 LSA with these prefixes or the RIP prefixes coming from RIP, right? So ultimately what is happening again? R2 is converting this type 5 LSA into LSA 7, okay, advertising into an SSA. R3 when it receives LSA 7 converts back to LSA 5 and advertise to rest of the OSPF domain. But again, these these particular LSA 5 are still not allowed. Why? In an SSA. Why? Because R3 doesn't have any capability to generate LSA 7. Only ASBR can do that, right? So you would see here R2 doesn't have those routes. Which routes? Do show IP route. It doesn't have these routes 192.168 1.0 routes. So if it doesn't have any of the routes, R1 will also not have these routes. If R1 doesn't have the route, that means show IP route. That means the reachability is not there, right? Show IP route 192.168 1.0. It doesn't have, right? 1.32. So again, even using using the NSSA also, you cannot reach. The objective is not completed here, even though you configure NSSA. Yes, you are able to redistribute. You are able to advertise. Yes, these routes you would see on R7. So if I go to R7, right, and do show IP route, these routes you would see. Which one? These 172, all these four routes, 172.16, 101.0. You see that? So these routes are finally reaching R7, but R7 routes are not reaching here because of this. You have configured NSSA and because of limitation with R3 ABR. So there is a remedy of it. What is the remedy? You need to, along with NSSA, you need to use one more command, which is this one. Default information originate. You need to use this command. So as soon as you use, what would happen? The same concept. ABR will convert type 5 LSA, right, as a default route and advertise to NSSA domain. So if I go to now R2 and say do show IP route, you would see immediately N2 default route has been created. Means all LSA 5 is now suppressed, which is coming from R4 to R3, has been converted into default route. And R1 would also see, you know, uh, these routes. You see the default route. R1 also has a default route now. So ultimately the reachability is possible, but then remedy was to use this additional command, which is default information originate. Now, if you don't want to use it, okay, that's the difference basically between NSSA and totally NSSA. There is also one totally NSSA. So in NSSA, the reachability won't be possible, right? But then remedy is to use additional command, which is default information originate. Due to some reason, if you don't want to use this, then what you can use it, I would just remove this command, by the way. Um, so router OSPF 100, and I would say no area 23 NSSA. And instead, I would use area 23 NSSA no summary. This is called totally NSSA totally NSSA area 23 NSSA no summary. This is called actually not so stubby totally, not so stubby area totally. Okay. So what happens in this? Now, without that default information originate, R3 will act like what we discussed the same. So R3 would receive all LSA 5 from R4, right? So do show IP route, and you see all LSA 5 it is receiving. Instead of this, it would generate the default route, which is again inter-area default route. See, the difference here is the default information originated when you used, right? That time it generated the N2 default route. You see, N2 default route. When you used additional this command, which one? This default information originate here, this one in an SSA. But when you are using totally NSSA, it is only generating the default route, which is inter-area default route. That is also different. See, you need to watch this video again and again, to understand this concept and the difference. Make a note that this is the difference in N1, this is the difference in N2, E1, E2, then difference between NSSA and totally NSSA, stub and totally a stub, right? So you need to note it down, maybe repeat this video again and again, go through it. But it is little confusing because it requires lab verification. But yes, when you see this happening in the lab, that would clear your all doubts. And these things are, to be honest, these things are like you cannot even remember after some time, even though the concept is clear, right? After some time, you would see that okay, you most of the concept you have forgot. So uh, yeah, just repeat again and again, pause it, make a note, and then understand the difference. Okay, so that's about that basically covers all the point which are listed here in our agenda. So yeah, with that, I would say thank you for watching and stay tuned. Please do subscribe, the channel to get the latest videos. Thank you.